Hello and welcome to your very first flipped video. So you are going to be taking notes while I have things up on the screen and I explain them, so they should be going in your composition notebook. I only expect you to know a part of it, so what your job is to write them down and then write questions in the margins. Ask me things on the next class. I'll see you guys on Friday. Bring questions to class and then we are going to be practicing this within the class. So your title is Graphing and Interpreting Linear Functions. So the very first thing is a linear function. It is when you graph points from the function and they lie on the same line. So for example, I have the points -3, 2, -1, 1, 1, 0, and 3, 1, and if you graph them, they are on a line. Remember, you can pause this and write if I'm going too quick. The slope of a line is the steady rate of change of that line. It will be steadily going up or steadily going down. There's a couple ways that you can refer to the slope. That would be rise over run, which is the up or down, depending if it's positive or negative, comma, over to the right. It is also the change in y. This little delta symbol looks like a triangle, is the word change. Change in y over the change in x. We're also going to talk about y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We'll later in this video go over an example of how to use that. And all of these equal m. So m stands for the slope. The y-intercept is where a line crosses the y-axis, also known as b. So b is our slope. Sorry, our y-intercept. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So we're going to talk about how to graph a line if you're given the slope-intercept form, which we have talked about before, so hopefully this is a little bit of a review. So first, you're going to start at b, which is your y-intercept, and then from b, you're going to create that slope triangle. You're going to go up and to the right or down and to the right, depending on if it's a positive or negative slope. So we're going to practice a couple. So our first example, we have y equals 2/3 x minus 3. So the slope is 2/3, which is positive. So our rise is 2 and our run is 3. And our y-intercept is -3. So we're going to first start at -3 on the y-axis. So you're going to count down to -3 on the y-axis. And then we're going to create that slope triangle. So from your y-intercept, we're going to go up 2 and to the right 3. And that's our second dot. And then you can draw your line, and you guys are just sketching it in your composition notebook. A line such as y equals -3x, there's nothing being added. The slope is -3, that's always the number with x. Since there's no number being added, that means the y-intercept is 0. So your first point is at the origin. If your slope is not a fraction, make it 1, put it over 1. So I'm going to go down 3 and to the right 1. It's down because it's a negative. Make sure you go to the right. So down and to the right. Okay, now interpreting a graph. So we're not just going to graph lines. We're also going to say, what are they telling us? So let's just say that h of t, which is that graph right there, shows us the height of a water storage tank. So we have water being stored in a tank. And we want to know what is the height at t equals 0. So at the beginning. So if we look at the very beginning, at t equals 0, our height at t equals 0, our height is up here. So that is 12 feet. If I wanted to know the height at t equals 2, I could go to 2 and I could go up to here, and that is 9 feet. So what's happening to our water storage tank is it's emptying. Hopefully it doesn't have a leak. Hopefully there's emptying out on purpose. And when the tank happens to be empty is right there. So the tank is empty right there. And at what time is that? That is at 8 minutes, assuming that this was minutes. Okay? Now, as I said earlier, we're going to talk about finding the slope between 2 points. So we use the y sub 2 minus y sub 1 equals x sub 2 minus x sub 1. Those subnumbers are just telling you where you get the number. So for instance, this point is x sub 2 comma x sub 1 comma y sub 1 because it's the x from point 1 and the y from point 1. This is x sub 2 comma y sub 2 because it's x from point 2 and y from point 2. Mathematically, there's nothing you do with those subnumbers. It's not an exponent. You're not multiplying or adding it. As soon as you plug in that number, those subnumbers are gone. It also doesn't matter which one you declare as 0.1 and 2. So let's just call this one 0.1 and this one 0.2. So my y sub 2, which would be here, is 7, minus my y sub 1, which is 4, over, so I'm subtracting them. I'm subtracting my y's, because remember it's the change in y over the change in x. Subtract your y's over subtract your x's. And then the denominator is x sub 2, which is going to be negative 2, because that's the x value from the second point, minus x sub 1 over there, which is 3, and you get 3 over negative 5. So there's your slope between your 2 points. You can also find the slope in terms of a table of values, and it's the same idea. So I'm going to declare this 0.1, and I'm going to declare this 0.2. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the y from the second point is a 3. The y from the first point is a negative 2. The x from the second point is a 5. And the x from the first point is a 3. Now, be very careful with your negatives. This does have minus a negative, which basically just means a positive. So this is 5 over 2. So another thing about linear equations is, what are they telling us? What is going on with a linear equation? This is interpreting a linear equation. So let's just say I had an equation for the number of leaves on a tree during fall, and it was y equals negative 15x plus 5,000. Well, we know with y equals mx plus b that this is the y-intercept. But it's also the starting point, so it has to start somewhere, which means we have this lovely tree, and at the beginning, it has 5,000 leaves. So it's going to start with 5,000 leaves. Now, this is the slope, which is the rate of change. But if you'll notice, it's negative, which means in terms of leaves on a tree, that means that they're falling off. And it's fall, so that makes sense. So that means that if x is in days, that it's losing, so 15 leaves are falling off every day. So 15 leaves fall off every day. Okay, that's interpreting. Really quick reminder, very last thing that we need to go over. We have already talked about isolating. We did a little bit of a review at the beginning of the year. If I wanted to isolate this for y, I first have to get my negative 3y by itself. I'm going to subtract 5x from both sides. I'm going to have negative 3y equals negative 5x plus 12, because on the right-hand side, those two cannot be combined. If I divide everything by negative 3, every single term by negative 3, I'm going to get y equals, negative over negative is a positive, 5/3 x minus 4. And then, since I have isolated it for y, if I wanted to graph it, I have my y-intercept right there, and I have my slope. Okay, make sure you guys got everything written down. Bring your questions to class. Watch parts of it again if you needed to, and I'll see you on Friday.